There are many things that cause a BACnet MSTP network to function slowly and inefficiently. In this series of videos, we're discussing common mistakes that people make and ways to solve them. Let's look at problems with MAC addresses and max master. One common problem occurs when max master is set too high. Any master device added to a network must be discovered by the other network devices for it to receive and pass the token. To do this, the BACnet standard requires that every master device on the network periodically poll for new masters between its own address and the next known master's address. The BACnet standard sets the default max master value to 127, so that way a device added to the network can find any master. However, if there are fewer than 127 devices on the same network, this is an inefficient use of the max master. This slows down the network because the BACnet standard calls for at least one poll for master, or PFM, for every 50 times a master receives or uses the token. Each address in the gap between the addresses is checked during the cycle to determine if a new device has been added. For its part, any new master must respond within 20 to 35 milliseconds. One strategy sometimes used to build in space for future masters is to leave gaps in MSTP addressing for existing devices. Either way, more PFM cycles add up to increased latency. On the other hand, the network can also be slowed when the max master is set too low. Since the max master keeps the PFM cycle from exceeding a set value, the max master set equal to the MAC address less than the highest master on the network means that the final device, or any device with a MAC address greater than the one assigned as a max master, will never receive the token. For example, if there are 16 devices with MAC addresses ranging from 1 to 16, a max master of 16 prevents a PFM cycle for addresses greater than 16. If a device is added at MAC address 17, the network will not see the new device unless the max master is changed to incorporate it. To fix this, use the most efficient addressing scheme for an MSTP network. Number your devices consecutively and set the max master equal to the highest MAC address used in the system plus a buffer. Another problem starts from a network configured with a loop. A network loop is a configuration where there is more than one signal path between two computers or devices, causing data packets to be repeated. This results in a broadcast storm that floods the network with repeated messages. A loop forms when a path is created from one router out to one or more routers and then back to the original router without using a different network number. Any type of network can form part of this loop. The solution is to ensure a single path from a router out to one or more routers and back to the original routers using the same network number. Those are our recommendations for avoiding slowdowns caused by MAC addresses and max master on a BACnet MSTP network. For more information about the other BACnet MSTP network issues, please check out the other videos in this series. And to learn more about the other solutions from the building geniuses at KMC, visit us on the web at kmccontrols.com.